Grade 7. Welcome to Miss Moises Math Virtual Classroom. Today, we will discuss about square roots. Give the value of the following. So number 1, 5 squared. So it is the same as 5 times 5, which is 25. Number 2, 3 squared is 9. Number 3, 9 squared is 81. Number 4, 7 squared, or multiply 7 by itself, which is 49. Then number 5, 11 squared, or 11 times 11 is 121. Exponents are used to abbreviate repeated multiplication. For instance, 5 times 5 can be written as 5 squared, where 5 is the base and 2 is the exponent. Exponential notation, 5 squared is 25. So again, 5 is the base, 2 is the exponent, and 25 is the power. The base gives the number that is being multiplied. The exponent tells you how many times the base is used as a factor. The power is the product of equal factors. A perfect square is the square of a whole number. The number 25 is a perfect square because 25 is 5 squared. The number 10 is not a perfect square because there is no whole number that can be squared to get 10. We know that 49 is the square of 7 because 7 squared is 49. We can also say that 7 is the square root of 49. The square root of a given number is the number that can be multiplied by itself to produce the given number. Notice that negative 5 is also a square root of 25 because negative 5 squared is 25. In symbols, square root of 25 is positive or negative 5. Notice that square root of 25 has two roots. One is positive and the other is negative. The positive root is called the principal root. The symbol, so this symbol is called the radical sign. Then, 25 is called the radicand. When we say radicand, it is the number under the radical sign. So, square root of 9 is positive or negative 3. The square root of 81 is positive or negative 9. Square root of 0.49 is positive or negative 0.7. The square root of 4 over 121 is positive or negative 2 over 11. So just get the square root of the numerator for the numerator of the answer and square root of the denominator for the denominator of the answer. In the real number system, the square root of a negative number doesn't exist. This is true because there is no real number a for which a squared is negative. Therefore, an expression like square root of negative 25 has no meaning in the set of real numbers. On the other hand, the square roots of non-perfect squares are irrational numbers. They are non-repeating and non-terminating decimals. Examples: square root of 2 is positive or negative 1.41421356 and so on. So it is non-repeating. There is no pattern, no repeated. So non-repeating and non-terminating. There is no last digit. It never ends. Square root of 7 is positive or negative 2.645 and so on. Square root of 10 is positive or negative 3.1622776 and so on. So since the root is irrational, we cannot get its exact value. However, we can approximate its value by finding two consecutive integers that include that irrational number. So let us have this one. Write rational if the principal root of the given is a rational number. If irrational, and irrational if it is not. If it is rational, give its principal root. Number 1, square root of 36. So look at the radicand. The radicand is 36. So you will identify whether the radicand is a perfect square. So these are some or first 8 perfect square numbers. So 1, 4, 9, 16, 25, 36, 49, and 64. So 36 is here, so it is a perfect square. So the principal root is 6. So the principal root is 6. So to check, so when you multiply it by itself, the answer is the radicand, 36. Next, number 2, square root of 7. So 7 is not a perfect square. It is just between 4 and 9. So it is irrational. Next, square root of 0.09. So the principal root is 0.3. So it is still rational. So it is terminating decimal, so it is rational. Next, square root of 25 over 49. So 5 over 7. Then number 5, square root of 50. So it is between 49 and 64. It is not a perfect square. So it is irrational. Next, tell between which two consecutive integers each number lies. Example number 1, so square root of 34. Just get first the radicand. So radicand is 34. So it lies between what two perfect squares? So these are 25 and 36. Then after that, so again, so 34 is between 25 and 36. So after identifying the two perfect squares, get its square roots. So the square root of 25 is 5. Square root of 36 is 6. So the square root of 34 is between 5 and 6. So that is the answer. So those are the two consecutive integers, 5 and 6. Next, number 2. So number 2 given is the negative square root of 73. So negative square root, so we have negative 73, so it is lies between negative 81 and negative 64. So don't forget that it is a negative. So negative 73, so it is between negative 81. So get the square root of 81. So which is 9. Then square root of 64 is 8. Then attach the negative sign. So the negative square root of 73 is between negative 9 and negative 8. So that is the answer. Okay, that is all for today, and thank you.